Hello guys, welcome to Infinite Insight Geometry, lesson 2.4, angles. Alright, let's begin. So, before we talk about angles, we first have to talk about rays. A ray is a portion of a line that starts at one endpoint and extends infinitely in the other direction. Think of a line, but it stops at one point and it just keeps on going in the other direction. When you're naming a ray, you gotta say the endpoint first and then another point on the ray. For example, ray AB is not the same as ray BA because ray AB has its endpoint on A and ray BA has its endpoint on B. Remember that. Now, what is an angle? We are finally done with rays. We can finally move on to angles. What is an angle? An angle is a geometric figure made by two rays that share an endpoint. So you have two rays and they share an endpoint. For example, ray AB has endpoint A, so you could say ray AC. And so you could say ray AB and ray AC make an angle. The vertex is the endpoint of both rays in the angle. So for the angle of ray AB and ray BAC, you could say the vertex is A. When naming an angle, the vertex always becomes between the other 2 points. For example, in angle ABC, B is the vertex. So if we wanted A to be the vertex, we would say angle BAC, not ABC. The degree is a measure of an angle. A full rotation of an angle is 360 degrees. That's what you get when you go a full circle around an angle. Degrees are notated by this symbol. It's the same symbol where you would use degrees in Celsius and Fahrenheit. But 360 degrees is just 360 degrees notated by that symbol. Angles can be categorized by their measure in degrees, and you will see a lot of different angles over here. You can see the acute angles, less than 90 degrees, right angles, exactly 90 degrees, obtuse angles, greater than 90, less than 180, straight angles, exactly 180, reflex angles greater than 180, less than 360, and a full angle exactly 360. A full angle is also called a full rotation. So you can see all of these types of angles. They are all categorized by their degree number. There are certain ranges that need to be fulfilled. The only really important thing to get from here is that right angles are really important. Right angles are almost everywhere in geometry. They are exactly 90 degrees, they are exactly perpendicular, and that will be important for a lot of later lessons. The interior of an angle is the region inside the two rays that form the angle. So if you were to say the interior of an acute angle, it would be the angle less than 90 degrees, and everything inside that angle. Now the exterior of an angle is the region outside the two rays that form the angle. Now here's the thing, reflex angles and straight angles are really hard to remember what is the interior and what is the exterior. Remember that the interior will always be the part of the angle that is less than 180 degrees. So for example, if you have the reflex angle, the interior of the reflex angle would be the portion in between the acute or obtuse angle that is inside of the reflex angle. And the exterior will be the outside of the reflex angle. Now that we have that done, we can move on to congruent angles, which are angles that have the same measure. This is no different from congruent segments. If congruent segments have the same length, they are congruent. So if two angles have the same degrees, then they are also congruent. So that's a lot of definitions for lesson 2.4. Feel free to just scan through it because it's a lot. You have a ray, an angle, a vertex, a degree. All of these types of angles, the interior and exterior of an angle, and congruent angles. This is a lot, but there's even more because we also have a postulate. but this postulate will be pretty easy because you already saw the segment version of it. If you remember the segment addition postulate, you would see that AB plus BC equals AC if those were segments. Pretty simple. It's the same concept with the angle addition postulate. If point O is in the interior of angle ABC, then ray AO can be drawn so that the measure of angle ABO plus the measure of angle OBC equals the measure of angle ABC, and you can see in the drawing. If you take the measure of angle ABO, defined by the points A, B, and O, where B is the vertex, and OBC, where B is also the vertex, then ABC is just the sum of those two angles. Also note, whenever I say M angle, it does not mean mangle or something like that. It just means the measure of the angle. You will see this all the time. M followed by an angle sign. This is the standard notation that most teachers in geometry class use for making sure that we refer to the degree measure of the angle instead of the angle itself. There is a difference between the angle and the number of degrees it has. Keep that in mind. So we have this problem. We need to prove that JML is a right angle. And we see that we have the measure of angle JMK is 52 and the measure of angle KML is 38. So how will we start to answer this question? I'll give you a moment to pause. Now the two-column proof is this. This is the full two-column proof. You first have to start with your givens. The measure of angle JMK is 52 and the measure of angle KML is 38. And we're trying to prove that JML is a right angle. So we refer to the angle addition postulate. Since JML, K is in the interior of JML, we can say that angle JMK plus angle KML equals angle JML. And this also refers to their measures. The measure of angle JMK plus the measure of angle KML equals the measure of angle JML. Now we can just substitute the values that we were given, 52 and 38 equals the measure of angle JML, used by substitution. Simplify by just adding the 2 degree measures together. The measure of angle JML is 90 degrees, and we know that a right angle will always equal 90 degrees, and any angle that is 90 degrees is a right angle. So angle JML is a right angle by the definition of right angle. I hope this makes sense to you. Really, it's just applying all of these different definitions and postulates to use. These are the easy two-column proofs, which we will need to establish harder two-column proofs in the future. And that'll be all for today's lesson. If you liked the video, please like and subscribe. I have my Gmail down below in the description if you want to email me any questions, and I will see you all next time.